Here's the homework. You only had the odds. No, I did this last year in the second semester, and I gave those students all of them. So you didn't have all of them, but this is the work I did on that last semester. So I already had this. So you only did the odds. Now, I tried to color code this so that you could see the changes after the transformations. Now, some of them, there wasn't that many. But once you got down to 53, then there was a couple transformations. Okay, so that's basically what you're looking at here. And I'm just going to double check. I do believe I gave this to you in the going over homework. Oh yeah, it looks like I did. Okay, so I did all of them, but you only had to do the odds. All right. All right, again, I'm going to jump around a little bit maybe. I don't know. We'll see, but make sure if there's one you want me to go over, let me know. Well, the first one, you don't really need to use transformations for this one, because if you know this is the graph that's going to get smaller as you go to the right. But if you want to, you could just think of this, well, we're changing the signs of the x, so flipping over the y-axis. And again, the horizontal asymptote is never going to change unless you go up and down, right? So e to the negative x, so when you get e to the negative 10, that's pretty small. It's pretty close to 0. So as you go to the right, this is dropping down close to 0. All right, so the range would be anything greater than 0. I did that down here, range and domains, in case you want to know. All right, and 51, this is a horizontal translation. So the point that would have normally been on the y-axis at 1 moves over 2 places to the left, right? So the two things you want to focus on, the original y-intercept, where does that move to? Does it move at all? And what's the horizontal asymptote? That's the two characteristics of these graphs that will help you make the sketch. Okay, so then here, number 53, you had reflection across the x and reflection across the y. So it's going to be like this and then flip over. So that's where the green graph is now. So it used to be at 1, now it's at -1. Horizontal asymptote hasn't changed until you do the next step, which is move it up 5. So when you move up 5 from here, the y-intercept is now 4, horizontal asymptote is now 5. Okay, and the 55 is a similar thing. Now this one you had a domain dilation, right? So we're going to have to double from the graph we get to once we get to the domain dilation. So we're going to stretch this twice as far from the x. So after the reflection, it's just like number 53, you wind up with this green graph. And then domain dilation, you're going to need twice as much x. So notice I'm stretching the orange graph left and right farther away. And then that graph moves up 2. So from the -1, go up 2. The horizontal asymptote is now 2. Y-intercept is now 1. Okay. Now with all these, there's never an issue with an exponent, unless there's another operation. So you might have something in an exponent that is the square root. But if there's nothing in an exponent that's operationally problematic, never a problem for the domain of exponential functions. The range is based upon the horizontal asymptote. So you're either above or below the horizontal asymptote to get all the ranges. Okay. Now, some of these equations here were straightforward, right? So 57, pretty straightforward. Now, 59, you want to convert to base 2, so 2 to the 4th power. And then in order to make these match, you would have to have a negative exponent. So that would have to be -4. Okay, and in 61, again, very similar. Now you want to get based upon the base of 5. And then 63, you want to convert to the base 2, and then you can put the exponents equal to each other. Same thing with 65. You want to convert to the base 3, and then you can put the exponents equal to each other, which in this case, for 65, you wound up with a cubic. So remember, you don't want to divide by x. Get it equal to 0, use the zero product property. That way you'll get all the solutions. If you divide it by x, you're going to miss 0. Because 0 works. Because 3 to the 0 does equal 9 to the 0. 0 actually works. Okay, and then same thing with 6, except now when you convert the 4, that winds up with an exponent of 2x squared. Now when you put the exponents equal to each other, again, don't divide by x. Create a zero property, factor out, and then you'll get all the solutions. Okay, and then 67, you want to convert to base 2. So this time you got to convert 8 and 16. And then once you do that, the two exponents are equal, and then you can solve from there. And then 69, same thing, convert the 27 to base 3, and then you wind up the two exponents can equal, and here you can factor and solve. All right, and then now 71 is where I would have thought this gets a little tricky, because you've got to be aware of exponent properties. So here you can convert to all the common bases, and then on the left side, if you multiply the common bases, you add the exponents. So that's why you get 2x plus x squared. And now we can put the exponents equal and solve, and you can factor. That's always a good idea. And the same thing here. It's just base e. And then number 75, you want to go ahead and get everything easier to deal with first step. So I changed that to e to the negative 2. Now, when you multiply common bases, you add the exponents, and now we can write our equation based upon the exponents have to equal, and then we could factor this. Okay, and then here it's just a matter of plugging into the formula. So that wasn't too bad, I hope. But let me see, was there one thing I wanted to point out here? Yeah, don't get into the habit of using a calculator all the time. So sometimes, like, you can do this without a calculator if you understand what negative exponent means. So flipping this over, that becomes 2 to the second power, 3 times 4, and then minus 2. So, you know, now the last part might have been a little difficult, because you have to kind of interpret what you do. They give you what something equals based on 4. And so you want to take the problem and rearrange it so that you can base it on what equals 7. So how can you change this to 4 to the x? Well, just go ahead and rearrange the exponents. And now you can replace the 4 to the x with 7 and take it from there, right? And so the same thing here with 85. They give you something that equals 2. So we want to rearrange the original problem so we can get a 3 to the negative x. And so the way to do that, if you rearrange the exponents, this will work. And then you can replace the 3 to the negative x with 2, and then you can solve it from there. Okay? All right.